What's the dumbest misunderstanding you've had with a student? I was teaching high school chemistry, and we were in the middle of our acids and bases unit, pH scale, common solutions, the usual stuff. For the most part, my students were grasping it, but Jake was struggling. Jake was one of those students who tried hard, participated in class, asked questions, but pH completely threw him. No matter how I explained it, he couldn't wrap his head around the idea that lower numbers meant higher acidity. To him, bigger always meant more, so the concept that lemon juice at pH 2 was more acidic than baking soda at pH 9 just didn't click. On lab day, I set up stations with household solutions: vinegar, lemon juice, soap, milk, soda, ammonia, and so on. I had them test and record pH values using strips and a color chart. When I reviewed Jake's worksheet, my stomach sank. He had written that baking soda solution, which tested at a pH of 9, was extremely acidic, and that lemon juice at pH 2 was barely acidic. I pulled him aside after class. "Jake," I said gently, "you're still mixing up the pH scale. Remember, it runs from 0 to 14. Lower numbers are more acidic." He nodded, confident. "Yeah, I get it now, like golf scores." I blinked. "What, you know?" He continued. "Lower is better." That wasn't what I meant, but I figured, hey, if it helped him remember. Except the next day, he handed in homework labeling battery acid, pH 1, as basically neutral, and milk, pH 6.5, as corrosive. He also wrote that orange juice might be a good base cleaner because it had just a tiny bit of acid. At that point, I realized I needed to go visual. The following class, I set up a short demonstration. I put on gloves and safety goggles and brought out 2 labeled beakers, one with diluted vinegar, pH tilde 3, and one with diluted ammonia, pH tilde 11. I explained that vinegar was acidic and ammonia was basic. Then I asked Jake, which of these is more acidic? He pointed straight to the ammonia. "But Jake," I said, "the vinegar has a pH of 3 and the ammonia is 11. "Exactly," he said. "And 11 is way more than 3, so it's way more acidic." I took a deep breath. "No," I said. "Lower pH means more acidic. Think of the scale like a thermometer but upside down. The colder it gets, the lower the number. And with pH, the more acidic it is." He looked unconvinced. Then casually, he added something that made it all click. "Plus, my dad's a pool guy, and he's always saying he adds acid to raise the pH." So, there it was. Jake hadn't misunderstood the science. He'd been misinformed, repeatedly, by someone he trusted. His dad had been telling him over and over that adding acid raised the pH in pool water. And Jake, being a logical kid, took that at face value. Why wouldn't he? His dad managed pools for a living. One phone call changed everything. I called his dad that evening and gently explained what we were covering in class. He was friendly and admitted he always said add acid to raise the pH because that's what the customers expected to hear. He confessed that in reality, he added acid to lower the pH, but saying raise the balance made things simpler for clients. "Didn't realize I'd confused him," he said. "I'll fix it." The next morning, Jake walked into class, dropped his bag, and said, "Okay, so apparently my dad's been lying to everyone." We all laughed. After that, something shifted. Jake's grasp on pH snapped into place like a puzzle piece he'd been forcing the wrong way. He nailed the next quiz. In labs, he started helping other students. I overheard him once explaining to someone, "It's like acidity goes backwards. Lower number, stronger acid. Think of it like reverse volume." That year, Jake ended up with one of the highest lab scores in the class.